Hi everyone, in this video we have piecewise functions and you have to find the first derivative of these functions. In part A we have the function of x equal x cubed plus 7x plus 1 and the interval x greater than or equals 2, and we have 20x when x less than 2. So if you want to find the derivative f prime of x, it will be the derivative of the first function 3x squared plus 7 when x greater than 2, not greater than or equal, because you have to check the differentiability around x equals 2, and the derivative of the second function in the second interval is 20 when x less than 2. Now you have to check the differentiability around x equals 2, since 2 is a common between the two intervals. As you know, greater than 2 is 2 from right, less than 2 means 2 from left. So again, you have to pay attention to this note. You have to check the continuity, then differentiability for the common x. Here 2 is a common x between the two intervals. So first you have to check the continuity for x equals 2. So you have to replace 2 in the two functions you have in the original function, and you will get 2 cubed plus 7 times 2 plus 1, and you have to check if this is equals to 20 times 2. We have 8 plus 14 plus 1, and here we have 40. So you will get 8 plus 15, and this is equals to 23, and 23 not equals to 40. So f of x is discontinuous at x equals 2, which means it is not differentiable at x equals 2. So f prime of 2 does not exist. So you have to complete here, and you have to write does not exist when x equals 2. Now in part B we have g of x equal x squared minus 16x when x less than 9, and we have square root of x when x greater than or equal to 9. Similar with the first part, you have to find g prime of x, and this is equals to 2x minus 16 when x less than 9, and we have the second function square root of x, and the derivative of the square root is the derivative of the inside function divided by 2 multiplied by the same function when x greater than 9. Don't put less than or equal or greater than or equal, because you have to check the differentiability around x equals 9, because 9 is common between the two intervals. As you see, less than 9, it means 9 from left, greater than 9 means 9 from right. So again, you have to deal with this note. You have to check the continuity and then differentiability for the common x. 9 is common between the two intervals, so you have to check the continuity for x equals 9. So you have to replace or plug in the value of x equal 9 in the first function. You will get 9 squared minus 16 times 9, and you have to check if it's equal square root of 9. Simple calculations you will see that the left hand side is negative 63, and this is not equals to 3 again. G of x is discontinuous at x equals 9. So it is directly not differentiable. No need to continue and find the derivative. So g of x is not differentiable at x equals 9, which means that f prime of 9 does not exist. G prime of 9 does not exist. So you have to write here does not exist when x equals 9. Now what about part C? In part C we have two common x. The first one is 1 and the second one is 3. But first you have to find the first derivative. F prime of x equals, here we have 2x when x less than 1, and for the second one the function in the second interval is a constant, so the derivative is 0 when x greater than 1, less than 3, and the third function in the third interval is 5 minus 2x, and the derivative is negative 2 when x greater than 3. Now you have to start with the first common value, which is 1. Here we have 1 from left, and here we have 1 from right. So we will start with x equals 1, and you have to check the continuity at x equals 1. So you have to replace 1 here and replace 1 in the second function, and you will get 1 squared equals to 1, and this is a correct statement. So f is continuous at x equals 1. Now, since it's continuous, you have to check the differentiability of the function around x equals 1. So you have to find f prime of 1 from right then you have to find f prime of 1 from left. From right, it means from here we have 1 from right, and it's equal to 0, and f prime of 1 from left, from here we have 1 from left, and it's equal to 2 times 1, which is equal to 2. As you see, the two derivatives are not equal, which means that f prime of 1 does not exist. So f is not differentiable around x equals 1. Now with the same procedure, you have to check the continuity around x equal 3, then the differentiability. So the continuity around x equal 3, here we have in this interval we have x less than or equals to 3, which means 3 from left, and here we have x greater than 3, which means 3 from right. So you have to plug in 3 for the two functions. We have 1, 3 from left equals 5, and you have to check if it's equal 5 minus 2 times 3. So we have 1 in the left hand side, and in the right hand side we have 5 minus 6, which is negative 1, which means they are not equal. So as you see, f is discontinuous at x equal 3, which means that f prime of 3 does not exist. So you can write here does not exist when x equals 1 and 3. So this is the idea. If you have common x, you have to check the continuity first for x, then you have to check the differentiability for the common x, and that's it. Thank you.